Okay, looks like it started, Lindsay. Great. Thank you for the introduction, Lindsay. My name is Luis Marinigo, and I lead into the New Signatures BI and analytics initiatives. Again, thanks everyone for joining today, and specifically, we will talk about the Internet of Things and what opportunities are related to IoT in particular. Okay. So today's agenda will cover these four areas. The first one will cover topics that will present the big opportunity for IoT. We'll discuss how to define IoT, what actions you can take to start realizing the benefits of IoT, and we'll finish up the presentation by walking through some use cases. Okay. So while there are a number of reasons for cloud market growth, one of the main drivers in the coming years will be coming from IoT. IoT is projected to be a massive opportunity. In fact, the IDC predicts the global economic value of IoT to reach 1.7 trillion by 2020. And according to McKinsey Consulting, 70% of the value enabled by IoT will come from business-to-business scenarios. And IoT-enabled devices will replace consumer devices as the largest device market in the world. So we know the market opportunity is going to be big, and that more and more companies are gearing up to offer cloud-based IoT solutions that will help them win as much of that opportunity as possible. And it goes without saying that many companies that are investing in developing their own IoT solutions, whether that's through their architecture and the use of these devices, they're capable of addressing the business challenges through end-to-end industry-specific IoT solutions that match their specific needs based on the industry that they are in. So the time to really start establishing the IoT, not only the thought leadership and the expertise within the organization, it's also important to start thinking about how to action on the opportunities that IoT provides. So we've seen some common pain points across all industries when it comes to taking action from data through intelligent analytics, whether it's an IoT problem, a BI problem, or an advanced analytics problem. Building an intelligent enterprise has always been a challenge, generally because of the following obstacles. It's slow to rationalize data. It's been slow to rationalize data in real time. It has also traditionally been expensive to build the analytics platform that can ingest the data and run it through an intelligent process and then finally visualize that data. Analytics in general is hard, especially when you move towards predictive analytics. You can see that the term data scientist is a term that is widely used to describe the person that can handle both the technology problems within analytics, but also the mathematical modules and algorithms needed to run a comprehensive predictive analytics solution. And finally, building a scalable architecture can be quite overwhelming. That's where that cloud story comes in. So what you see here in the slide are key inflection points that have helped address these common pain points. Hardware is no longer as expensive as it once was. Connectivity is accessible. The development of applications has become much easier, and there's been significant benefits from visualizations that help fuel demand for analytics, which in turn helps fuel innovation. So we're truly at a perfect storm for IoT. So here's a quick view of what IoT looked like in 2010. from the time you would leave your home to the time you would get to work to the time you would come back home again. You see that there's some connected devices, but still it's still early days in connectivity. You'll notice here that you've got your alarm clock all the way down to your microwave and your coffee maker to your television, but nothing is really that connected yet. So we fast forward to 2016, and this is what the landscape looks like today. We see devices that track your personal activity, smart home devices, and your entertainment systems. There's just a lot more to manage as we start to learn what to track and how to best utilize the devices that are connected to each other. So now we're going to discuss or help define what is the Internet of Things, or what we really mean by IoT. But I'll first talk about some of the basics. So I've stated already that IoT has recently emerged as one of the biggest trends in technology, but in fact IoT is not really that new. Many companies have been delivering IoT solutions for years. What's new really is the ability to bring all of the required components together to quickly, easily, and cost effectively connect these components. A combination of factors including, as I mentioned in the previous slide, falling hardware costs, more pervasive connectivity, the availability of cloud solutions have recently converged. So this is what makes IoT solutions more feasible for more scenarios than we have experienced in the past. So this slide introduces the basics of IoT. This trend is driven by a combination of factors that I just described. There's networks of connected devices connecting a vast amounts of data in the cloud, and organizations can really look at to incorporate new business models and new revenue streams by capturing raw telemetry data and uncovering the meaningful insights across the range of industries. So what makes up an IoT solution? IoT generally consists of four key elements: things, connectivity, data, and analytics. So things refers to physical things such as line of business assets, including devices or sensors. Physical things such as this relates to manufacturing, can relate to manufacturing equipment or interactive kiosks if we're thinking about a retail example. Connectivity, those are the things that connect to either the internet, internal systems, or ourselves. So if you think about, if you have a band or smartwatch, that generally would relate to connecting a thing to yourself. Data, this connection allows things to connect and communicate data from the environment, the users, or the things themselves. The data collected from the connected devices is the key reason why IoT is such a big opportunity. And the last step here, the last element, I should say, is analytics. So the massive amounts of data enables advanced analytics, which enables people or machines to take action. This is the most important piece here, because you can have things that connect to each other and you can have data, but the question is, so what? What do I do with that data? How do I take action? So companies can perform data analytics that produce business insights, enabling operational improvements that can lead to real results. Ultimately, IoT offers customers the opportunity to improve across their operations and develop new revenue streams, and overall transform their business. IoT is obviously still an emerging technology trend. It's still complex and it can be difficult to understand. So for customers looking to realize the optimal value from IoT, it's not enough to have certain siloed solutions that address the four elements I described in the previous slide. The value comes from when things are connected to each other and to a broader system that collect data, enables analysis, and facilitates communication back to the devices and to people. So point solutions within any one of these four elements isn't enough for customers to see value. The true value comes from the integration of the elements into a holistic platform. So it's very important that solutions need to be built upon a robust platform. And given the scale that the enterprise IoT solutions require in terms of sheer quantities and data and things, the ideal platform choice is usually a cloud platform. As the number of connected assets continue to grow, so will the volume of data connected from these devices. The cloud facilitates the integration of those assets and provides the scale needed to support the vast amount of data they produce. While on-premises deployments will continue to exist, hybrid and pure cloud deployments will be the best long-term solutions for many customers. So this is where I introduce Microsoft's Azure IoT Suite. So the Microsoft's Azure IoT Suite is the cloud platform that delivers a fully managed, integrated cloud service across all of those four IoT elements. The Azure IoT Suite democratizes IoT and provides the end user with infrastructure to connect devices, manage and analyze data, and predict and visualize without a need in a heavy investment in a technology or having to replicate or build this technology platform from scratch. The suite of applications gives the power of IoT and analytics to people that need to take action. So the Azure IoT Suite is made up of a combination of discrete Azure services bundled into one offering. These services can be purchased as part of a suite or as individual components through Azure. Services are added to this list as the offering expands its capabilities. So you'll see that maybe there's some other services that are added, for example, to device connectivity and management. And so it's an evolving set of service offerings that best address the needs of an organization. But the services can be broken down generally into these categories: device and connectivity, analytics and operational insights, visualization and dashboards, and then the supporting services. So I'm going to spend a little bit of time on this particular slide because there's a lot of services here, but I will not go into too much detail as to what they're sort of doing in more specifics. I want to just provide an overview and discuss how they connect to each other. So if we start on the left side, we'll look at Azure IoT Hub. The Azure IoT Hub enables reliable and secure bidirectional communications between millions of IoT devices and a solution backend. So what that means is that it provides a device-to-cloud and cloud-to-device messaging at scale. It also enables secure communications using per-device security credentials and access control. It provides extensive monitoring for device connectivity and device identity management, and it includes device libraries from most popular language and platforms. So this is where the data is coming in from the device, essentially. If we go to the right under Analytics and Operational Insights, you'll see that we have three services here. The first being Azure Blob Storage. This is the service that stores file data in the cloud. Blob storage can store any type of text or binary data, such as a document, media file, or application installer. Azure Machine Learning is really the engine behind the analytics. So I mentioned earlier that analytics is a very important piece of IoT, and that it can be complicated and hard. That's because predictive analytics, predicting anything, if you think about it, is challenging. But this is the service offering that allows you to build the modules and test the modules in order to determine how to approach your broader category of predictive analytics. I just want to mention as well that you can have an IoT solution without the predictive element to it. You can essentially have a remote monitoring functionality that allows you to manage your devices and monitor your devices without actually predicting anything. But as you move up the maturity chain in analytics, you might want to consider the predictive capabilities that Azure Machine Learning provides. And then we've got Azure Stream Analytics. So this is real-time event processing, the real-time event processing engine that helps to unlock the deep insights from your data. Stream Analytics makes it easier to set up real-time analytic computations on streaming data from devices, sensors, websites, social media, applications, infrastructure systems, and more. The final piece on at the top is visualizations and dashboards, and this is where Power BI comes into play. Power BI is an interactive dynamic tool for visualization and sharing insights. It turns data into action, and it really exposes the data to everyone at your organization that needs to take action. So visualizations are very powerful. That's where Power BI comes in. It takes sort of all of the intelligence that's happening from device connectivity to the operational insights and surfaces that information so that individuals can gain from those insights. The supporting services are at the bottom. So we've got the Azure App Services, which builds powerful web and mobile apps, allows for the building of powerful mobile apps that connect data to anywhere in cloud or on premises. We've got the notification hubs, which is the enables you to send mobile push notifications from any backend to any mobile platform. We've got DocumentDB, which is the schema-free NoSQL document database service designed for modern mobile and web applications. Logic Apps, which are part of the Azure App Service, makes it easier to build web, mobile, and integration apps. Finally, we've got Azure Directory, which is the cloud-based directory and identity management service for managing both users and devices. Okay. So this is a slide that shows how some of these pieces can come together. The Azure IoT suite incorporates all relevant Azure services, so you don't have to worry about connecting them all yourself. You'll also see that there are some services here that I did not discuss in the previous slide, such as the Event Hub. You can incorporate these Azure services as needed for your specific solution. So you can take the suite of applications and enhance them through other Azure services. So let's look at what's behind the Azure IoT suite. We're continuously spinning up IoT-enabled services on Azure, and with the IoT suite, we can connect these services together for your easy-to-use, proven solutions. So there's a lot of flexibility here. What you get is a strong architecture, fully extensible. You've got pre-built dashboards, rules and alarms. You've got device connectivity and management, and you've got guidance on how to tailor this architecture to specific customers. Okay, so now that we've talked about IoT and how it relates to the Azure IoT suite, we'll talk about how to take action. So I've said several times in this presentation that taking action is very important. So this is the piece where we try to answer, so what? What do we do with this? So we at New Signature help customers build towards a proof of concept that can demonstrate the shortest time to value for decision makers that are thinking about IoT. So shortest time to value really means we've got a concept and we need to present that concept to decision makers so that they can determine whether the IoT solution is something that can align to their initiatives. So we can work towards getting that proof of concept and showing and demonstrating that value pretty quickly. You can start by anybody on the phone today can start by playing with the Azure IoT suite and logging into Azure and accessing the pre-configured solutions, which I will show you in a couple of slides. But we typically follow this 5-step approach to building a proof of concept, but it can certainly vary from customer to customer. So we frequently have discussions around these 3 key business value propositions for IoT. You either reduce cost, you increase revenue, or you create new business opportunities. It's very important to dig deeper into these business drivers to help round out your overall business case. And that business case may include a more specific total cost of ownership or return on investment analysis. The business case can be part of the proof of concept, or it can be a standalone assessment of what it means to potentially incorporate an IoT solution at your organization. So you want to make sure that you've identified what's your overall strategy, what are your key business drivers, and what requirements support those business drivers, and then get to a point where what would it mean from a dollars and cents perspective to actually improve efficiency. So that's where you would have somewhat of a financial analysis that would incorporate elements of the TCO or ROI. In addition, you would look at the ROI specifically for enabling innovation. So if you're increasing revenue, you want to understand what is my return on investment to make that increase. Transforming business is really a longer term view. It can mean that you're investing in new business areas or new markets as a result to a potential IoT solution that you're thinking about. Okay, so in order to talk about IoT and any type of analytics opportunity or solution, it's really important to understand the maturity of your organization as it relates to analytics. Specifically where the organization falls in this analytics maturity model. While data is pervasive, actionable intelligence from data can be elusive. Organizations want to transform that data into intelligent action and sort of match those business goals that I discussed in the previous slide. To do so, you need to more easily analyze massive amounts of data potentially. And generally what we see is that a lot of customers are currently in the traditional BI space, where the analytics is looking sort of backwards at the data, at the historical data, and asking the question, what happened? Understanding, and then trying to understand why it happened. So it's sort of a reactionary approach to analytics. As devices and data and connectivity and all those things that we talked about earlier increase, then you start to move towards insights, and it can incorporate some predictive elements. So what will happen? And potentially move to the prescriptive side of the graph here, which shows how can we make it happen? How can we replicate something that we are trying to predict? And that's foresight. And again, getting to that level is hard. It's complicated for many different reasons. There's mathematics involved. The machine learning modules need to come into play. And so there's a difficulty there. What I will say is that IoT does live between these two spaces, so between sort of the traditional BI and the IoT advanced analytics spaces, because as I mentioned earlier, you can connect devices into an architecture, an IoT architecture, that allows you to monitor your devices. If you want to monitor and you want to manage your assets, then you can start to get that telemetry data, and it's important to let the insights from that data determine what you're going to do next. I think that a lot of times we want to incorporate the data into an intelligent architecture, and we want to then use that information to take an action. But sometimes before we take an action, as we connect the data to an architecture, we may find something interesting about that data without running a predictive model on it just yet. So it's a continuous learning process as you connect that data, and it is very much a proactive activity. So despite the fact that you may not be doing a predictive action within your IoT architecture, you're very much looking at how that data is going to allow you to move up the maturity line. So we can cater this approach and fall on the line however fast or slow you see yourself maturing. So every organization is different, and there's specific data points, data analysis methodologies that you can take into account once you've got those devices into the system. Again, it's very important to clearly understand what your current maturity is and what your future goals are, because that will help determine how fast you want to move up this maturity line. Okay, so the third step in our process towards building a proof of concept is identifying the project type. So I mentioned things like remote monitoring, asset management, and predictive analytics. Remote monitoring focuses on improving efficiency, so there's a short-term payback there. It's pretty quick. It doesn't really incorporate too much machine learning, or it doesn't incorporate the predictive side of the machine learning elements. So it's just quick and easy to set up your device streams into the Azure IoT suite and start to gain insights from your data. Asset management focuses on innovation to increase your revenue growth. So this is addressing that second business driver. So there's a medium-term payback here, and then predictive analytics requires a little bit more investment, but it's really focused on business transformation. That's that third business case there that I spoke about earlier. And this has a longer term payback. Obviously, there are project types that fall outside of these three because, again, every organization is different, every scenario is different, but it's a good way to start asking the question, roughly where would a potential project fall? And this aligns again to that maturity line, because remote monitoring in the maturity line of IoT would be lower on that line, and hence you would have a quicker payback there. Perhaps not as large of a payback as a predictive analytics solution, because in that case you're transforming a new business opportunity. Okay, so a focus of Azure IoT, a real point of differentiation, is the fact that there are pre-configured solutions in Azure. So within Azure IoT, the Azure IoT suite, there are pre-configured solutions that allow you to get started very quickly for common IoT scenarios such as remote monitoring, asset management, and predictive maintenance. You basically get a curated experience here for these scenarios with a pre-provisioned dashboard, rules, and events engine, and you've got your device registry. You can add your own devices, you can change your own rules, or you can quickly get started towards that quick time to value that you need in order to build that business case for IoT. This really allows you to get to the end point. So you're building your IoT solutions. For example, you get started quickly with remote monitoring, and then you can tailor to your needs and convert it to a specific solution. This solution is finely tuned for your story. The goal of these pre-configured solutions is to accelerate your time to value, as I've mentioned, and reach your endpoint much faster because you will have a good base for building the next phase of the project from then on out there on out. Remote monitoring demonstrates the connectivity and real-time telemetry data. Predictive maintenance incorporates the Azure machine learning capabilities to demonstrate the predictive analytics. Okay, so how do you actually set this up? This is a view from the Azure IoT suite, so you can access one of these pre-configured solutions. You sign in to the suite and you choose which solution you want to test out. Once you choose a solution, you'll see the out-of-the-box devices that Microsoft has connected to the pre-configured solution, and you can start to, what you see here is the live data from those devices. In this view in particular, we have a Power BI visualization embedded into the UI showing the live telemetry data. In this case, it's humidity and temperature on the top right, and the devices are on the bottom left. You can connect any device that you want to a solution and make customized changes such as monitoring different telemetry data or adding an alarm. Devices can be added simply within the provision solution. So for proof of concept, you can add any of those devices that you need to incorporate into this pre-configured solution for your specific use case. The data ingestion schema is fully customizable, so devices can accurately mimic the types of data and value variances expected from real devices. The real devices and sensors can be added using the available agent libraries and SDKs. I'm not going to go into too much detail here, but I wanted to just show that this is sort of how the process that you would go through to add the device. You can quickly provision and add these devices, and you can simulate the devices with the custom schema, and it does support multi-platform devices. So this view here, this is the IoT hub. So a couple slides back, I talked about what makes up the Azure IoT suite in terms of the discrete Azure services. In this case, we're looking at the IoT hub, and it's exposed through the IoT suite pre-configured solution, as you can see here. Devices and sensors communicate and receive instructions via the IoT hub, as mentioned before, and this allows for per-device authentication and secure two-way communication, device to cloud and cloud to device. Through the portal, the user can access the telemetry data about the status of individual devices. They can ping for a response and easily identify a malfunctioning device. So unresponsive devices can be removed, and there's the simple device identification and alignment can be achieved and also monitored here. Okay. So we are on step 5 now, which is to build the proof of concept. So the final step is really scoping and planning a proof of concept with your data and your devices. The benefits of a proof of concept is that you can start small and build up to a production rollout with limited resources and spend. You can learn from your data and make the right adjustments to your approach early on in the process. Okay, these are the list of 5 key components that make up a good proof of concept. You've got it enables you to add devices, so you have the flexibility to match your specific use cases. You can use existing software devices. You can leverage your own assets and cloud-based solutions. It's financially flexible, so you don't have to invest too much to get to a proof of concept. You can share the data and collaborate with individuals that are aligned to the potential IoT solution you're working on, and it's scalable. Um, so I think we've got a question, correct? How many IoT projects have been delivered? Can you share details? Um, so, uh, so this is a relatively new practice area for new signatures. So the what we've been the way we've transitioned into IoT is that we were focused primarily on BI projects and handling data both from an architecture perspective, but also from a visualization perspective. And we've matured ourselves, just like I've showed in the maturity line, towards the IoT offerings. Um, the IoT is very, very new. So the IoT hub just went to out for the general public, or out of preview, believe yesterday or 2 days ago, perhaps even last week. So although we have not delivered an end-to-end production rollout, we have and continue to work with building these proof of concepts. So we've done a couple of these, but in terms of an end-to-end solution, we have not, primarily because this is a pretty new offering, and the Azure IoT suite was really announced not too long ago either. So we're certainly taking the capabilities that we've built up through BI and analytics over time and incorporated our knowledge base towards IoT, which is part of that next transition phase. Good question. Okay. So in terms of the proof of concept and how we would build these, you've got 5 capabilities that we focus on, and that is the connect, store, manage, visualize, and collaborate. The way that this works is that we work hand in hand with customers and do a deep dive into these specific capabilities. So it's essentially a discovery process for delivering the proof of concept. And like I said, there's a specific approach for this. So the types of questions that we would look to is how many devices do you want to connect? What is your connectivity? What is your connectivity requirement? What are your security requirements? All the way down to visualizations. What do you want to see? What are your 5 KPIs that are important to you? So all of that is part of the discovery phase. But in addition, we do support the business value proposition. That is generally tends to be, like I said, a separate document that goes through the specific financials and the business case for an IoT solution. Okay, so we're at the final step here, and I'll walk through some examples. So before we get into examples, this is actually an example of project phases for IoT. Although the amount of time within each of these can vary drastically depending on a project, these phases represent a logical approach to delivering the end-to-end solution. So I kept saying short, small time to value for a proof of concept. 4 to 12 months are a business development case, followed by 1 to 9 months of a vendor evaluation, followed by 2 to 18 months of a proof of concept. Does not sound like short time to value. But these numbers right here are not very relevant to the type of work that we've been seeing. So you can spin up a proof of concept, an initial proof of concept, with the Azure IoT suite today. Ideally, you'd want to work towards a proof of concept that incorporates your own custom devices and your own use cases aligned to your own business case, and that is where those steps 1 through 5 come in that I described. And those generally do not take more than a month. So there's some discrepancies necessarily with the the time here, but the important thing I wanted to stress is the phases associated with each one of these the projects. That's the most important part, is the content. So making sure that you are developing a business case, that you're hitting those, you're defining what it means to be successful, right? What are the KPIs that you want to measure against? Buy versus build. Do you want to incorporate anything custom within your proof of concept? And then you get to a proof of concept where you want to not only demonstrate this in your organization, but incorporate other business decision makers that are outside of the IoT landscape to be part of this process. So that's a pretty critical step there, is to incorporate cross-functional teams in your proof of concept if possible. Once the proof of concept has been completed or delivered, then we start looking at specific rollouts, and these rollouts can be based on specific use cases and testing groups that you want to incorporate as you build out more devices and you expand on the scenario that you defined in your proof of concept. Once you've got the pilot completed, you can start moving towards a full scale rollout. So here is a use case that we're actually currently working on. I've kept the name of the company generic, but we're currently working on with a food processing company to build an IoT proof of concept solution for a particular processing plant. And specifically, we're connecting their current manufacturing sensors into the IoT architecture, pushing the data into machine learning, running specific algorithms that we've identified that are related to what we need to accomplish, and then we're running the analytics on the telemetry data. So if you think about it in terms of the maturity line, this is a little bit of a higher maturity IoT case because we're incorporating the machine learning element. The problem here is that we wanted to identify product waste. The food processing company has a team of data analysts and data scientists that can build out the intelligence behind the algorithms and the analytics. What we, New Signature, our main responsibility is not only to support that initiative on the analytics side, but to also provide the solution architecture that best suits their needs to make this happen. So we approached this project by setting up initially an in-person workshop, and we brought in their productivity specialist and walked through the different Azure IoT building blocks as it pertains to their problem. We walked through the different manufacturing steps that we need to take into account. We defined a preliminary architecture that led to this proof of concept opportunity. And this was completed all as part of the IoT workshop that we conducted. As you can see here, the technologies that we'll be focusing on for this particular proof of concept is the Azure IoT Hub, Azure Machine Learning, Stream Analytics, and Power BI. So we're currently in the proof of concept stage at the top right, but this is turning out to be a larger opportunity than the proof of concept, because there are other parts of the manufacturing plants that are excited and interested in replicating the work that we're doing here for this particular production line and replicating it across to others. So that's the beauty of a proof of concept, is that you're not losing any time working on something and building the base for a potential solution, because you can take that solution and expand on it, either by expanding more service offerings to it or expanding it to other product lines within your organization. So this is where we are at the moment. It's going it's going very well, and yeah, I think that what we're looking to do is build that intelligence architecture to support not only the the real smart people that are doing the algorithms, but also making sure that we are as efficiently and intelligently delivering a solution architecture that can handle the data ingestion all the way through data storage and intelligence, and finalizing it with the visualization. The goal here is to turn data into action. So the visualizations will hopefully allow individuals to get the insights that they need to be able to make the right decisions for each product line, and in addition, incorporate alarms that will allow the manufacturing process to intelligently make adjustments to handle and reduce the product waste, which turns into dollars and cents. So if we can replicate this across the organization, we're looking at significant amounts of dollars and cents saved for the entire company. Okay, so IoT. So I gave you a view into an example, a manufacturing example there that we're working on. IoT use cases can be found across several industries. Here we see some examples of IoT solutions, such as the predictive maintenance capability. We see that in manufacturing, oil and gas, and what we have here is customer experience. Despite the differences among these industries, there are similar IoT use cases across each. So you've got data processing and analysis examples for research and development. In this case, we've called out crop data analysis and prediction, seismic data. You have data processing and analysis within manufacturing and oil and gas. So you've got plant performance, which is related to the example I gave in the previous slide. You also have supply chain operations here for optimizing the supply chain, and data processing again for seismic data and visualization analysis as it relates to oil and gas. Okay, here is another breakdown of the key scenarios per industry. So in transportation, sensors, hubs, remote diagnostics are helping organizations improve tracking, routing efficiency, and fleet utilization. And also, telemetry also allows logistic companies to improve efficiencies of their infrastructure, more readily meeting the regulatory and compliance requirements. So real-time tracking of assets and people and goods is important in transportation. Manufacturing, you've got decreased connectivity costs and rapidly improving communications technologies is allowing organizations to take previously siloed data from the shop floor and specific manufacturing lines into a consolidated organization-wide view. So in the use case that I gave for the food processing plant, in access to Power BI or the telemetry data that is being developed in the proof of concept can be a centralized view of other parts of the manufacturing process. So that's certainly important. So you've got, in this case, remote monitoring and predictive maintenance can also be a key feature here in manufacturing. In retail, you've got you can leverage the store kiosks, presence tracking, as well as inventory and back office integration that can allow for increased customer satisfaction and operational efficiencies. So this is really based on the beacons and in-store integration with your mobile loyalty apps, for example, through IoT solutions. So the retailers can connect with their customers in real time in innovative ways. Some people don't like that, others do. So just an interesting scenario there. And you've got resources and utilities. I touched upon some of those in the previous slides, but really mining oil and gas and utility companies um, are experienced in leveraging sensors and real-time information on their operations to optimize their efficiencies. So they understand that it's important to have really good data from physical assets, and the fact that technological advances in the cloud and connectivity are allowing them to develop these deep insights into their operations is something that will certainly help reduce costs and improve efficiencies across their offerings. Okay, financial drivers. As a former financial analyst, I always like to come back to the financials here. What does this all mean in terms of dollars and cents? So this image provides an example of key financial drivers behind IoT implementations across the four categories. When you build a business case or when you are building a proof of concept, it is paramount that you determine the key financial drivers that will mean success for you. And then once you've put everything together, delivered the proof of concept or your production rollout, you can tie the results of the rollout to the KPIs and goals that you essentially set up at the beginning. So in this case, we've got lower maintenance costs, reduced downtime, lower inputs, and lower consumption and more efficiency throughput. So these are examples of the success metrics defined during the business case, and they're very, very important. So if we take, for example, the top line, energy, and we see that the use case here is predictive maintenance of alternative fuel generators, we can say without question that the reduced on-site repairs the repairs have been reduced by 50%. And then what does that mean in terms of downtimes for the customers as well, is that you're saving customers $1.2 million. So now you've got data is great because you're getting specific data coming into your IoT architecture, but then you're translating that into real numbers. And again, as somebody that has worked in IT economics and trying to figure out what productivity gains look like, it has always been a challenge to connect those productivity gains based on data that is not specific. So if you've got users that are increasing productivity because they have access to tools and business productivity applications that allow them to produce more, coming up with that number is incredibly challenging. But now that you have access to data and you can track that data throughout your architecture and see what the results are, you can connect those results to real tangible dollar values. So it's very important that those goals are defined at the beginning of this process. And if you can't define a goal specifically, well then I think that there's areas that you can define that you want to learn about as you move through the process, but always coming back to what is it that I'm trying to measure? What is it that I'm trying to accomplish? Okay, so that's the material of the webinar. I want to thank you guys again for joining, and I'll open it up to any questions.
Great. Thank you so much, Luis. If anyone has questions, they can type them in the chat. Aside from that, please know that the recording of this will be posted shortly, and you will receive an email follow-up with that link. So please let us know, and feel free to also send along questions if you are uncomfortable asking or having any issues. Happy to answer those and get those to Luis as well. Thank you so much for your time.
Thank you.